So as we think about this learning target about heat capacity, wanted to give you a couple examples and connect it all together to what we saw in the lab. So heat capacity is thinking about heating up substances. So imagine that you're at the beach and we have, of course, the sun shining. It's presenting the same amount of energy to all surfaces at the beach, both the sand and the water. So the sand and the water are exposed to the same amount of heat throughout the day. And I think you know from experience that when you're at the beach, the sand is going to heat up faster. So we see the temperature over here on the sand have a larger rise, where the temperature over here in the water will have a smaller rise in temperature. So what heat capacity is thinking about is putting that same amount of heat into some materials. And what we see over time is a bigger rise in some and a smaller rise in others. So in this example, we're seeing, again, the same amount of energy being applied to both locations, but the sand has a larger rise in temperature throughout the day. And that's what we're thinking about with heat capacity, is how much heat is going into a substance to increase its temperature by 1 degree. And different substances are going to absorb and reflect that heat differently, right? So some have a higher heat capacity, meaning they can take in more energy in the same amount of time, leading to a slower heat up or cool down. Those that have a lower heat capacity, they take in the same amount of energy, but it applies to their substance faster. So we see a faster heat up or cool down because that energy takes effect faster. So a higher heat capacity means it takes more energy to do the same thing as we're seeing in another substance. Therefore, it's a slower heat and cool. So when we think about the lab, we had 3 substances in our lab. We had the water, the corn oil, and then we also had the isopropyl alcohol. And one thing we kept the same was identical volumes of water, and we heated them up in our experiment for 10 minutes at the same temperature. And what we saw is a varied temperature change, right? The water had the smallest change in heating and cool down, where the oil and the alcohol had a much larger change in that same amount of time. So what that tells us is that the water has a higher heat capacity than the others. It's almost twice the heat capacity because it took the same amount of energy to heat up a much smaller amount, right? So we say that water has a higher heat capacity than oil, than the alcohol, than even the sand that we saw in the picture. So when we think about another example, one idea that came to my mind is this idea of pain tolerance, right? Different people are impacted by the same pains in a different way, right? We would say this lady here has a higher pain tolerance than this gentleman. They're both experiencing shoulder pain, but for him, he is feeling it and coming to his max pain level at a much faster rate, where she has a much higher pain tolerance. She can last under that same amount of pain for a longer period of time, just like the water. The water can be impacted, it is impacted less by the same amount of heat compared to the oil or the alcohol. So when we think about our final learning target, or our learning target information here, what we want to know is what is heat capacity. So we want to define, what do I know about high heat capacity compared to low heat capacity, right? What do I know about the amount of heat and time needed to heat it up if it's higher versus lower? And what did we learn about water? Be great to hear about and talk about your lab data here.